Hello, everybody. My name is Adrian. I work in Keeper Security's marketing team, and I'm joined today by Sylvain Hennig, who's one of Keeper's solutions engineers based in Ireland, and he's going to be perfect for our topic today on supply chain attacks. So, something to know about these is that supply chain attacks are a type of cyber attack that is often overlooked, and they can be more difficult to detect and prevent. Some of the reasons for that are that plenty of vendors aren't maintaining strict cybersecurity policies or using the best tools. Fortunately, when that happens, that's out of your control, right? But there are ways to protect your organization, your employees, your customers, etc., against these. So, Sylvain, I might interrupt you with a few questions, but the floor is yours.
Thank you very much. So yeah, we'll start today by talking about basically what are supply chain attacks. So supply chain attacks, they're also known as third-party attack or value chain attack or even backdoor breach. It's when a cyber criminal accesses a business network via a third-party vendor or through the supply chain. The thing is, supply chains can be massive and complex, and this is why some of those attacks are really difficult to trace. Many businesses work with dozens of suppliers for everything from ingredients or production materials to outsource work or even technology. So this is why it is so important to protect the supply chain and ensure the companies you are working with are as committed to security as you are. So there are three main type of supply chain attacks. So today we talk mainly about the first one, the software supply chain attack. It's it would basically require only one compromised application or piece of software inside your network to deliver malware across the entire supply chain. Attacks will often target an application source code, delivering malicious code into a trusted app or software system. Cybercriminal often target software or application updates as an entry point. Software supply chain attacks are incredibly difficult to trace, and cyber criminals often use stolen certificates to sign the code. So it will look legitimate as well. So that makes things even more difficult to detect. Then the two other types would be firmware supply chain attack. And this time it's about inserting a malware into the computer building code. And those ones are really quick to basically start in a split second. That malware could be basically running on the device. And basically they would, basically that malware would jeopardize the entire system on the device that has been targeted. And the last type, the main category of a supply chain attack would be hardware supply chain attack. And this time it depends entirely on the physical device. Cyber criminals would usually target a device that makes its way through the entire supply chain. So that way they can maximize the reach of the attack and the damage as well. So we talk about the solution today, how Keeper could help you basically protect you and your entire organization against the supply chain attack. So here I will start by showing you the documentation portal first. Everything I will be showing today, you will find a lot of information, further information on this portal. So docs.keeper.io. It's usually a great entry point. So at Keeper, we provide an enterprise password management solution where all of the employees of the organization will basically protect themselves with their own votes, where they would use that primarily to store passwords or any sensitive information that they would need to work. But then for the DevOps people, IT departments, we also have a set of advanced capabilities that they can enable inside the vote. It's based per role, so only the right people in the organization will see those extra features in their vote, and this is Keeper Secrets Manager. So this time it will help them remove any hard-coded credentials inside the source code, replacing configuration file secrets, pulling secrets from CI/CD systems like GitLab, GitHub, Jenkins, for example, protecting access to privileged passwords, API key, or basically any type of secrets that they could be using inside their application. It's basically a vault access machine to machine. Basically from their application, they can access to a part of the vault. Here, the main thing is you will see that your application, they do not access to the entire vault, but only to the secrets that they need to access in order to run. Inside the vault of the users that are using Secrets Manager, they would be able to specifically say, this application should access that part of my vault, and that other application should only access that, with specific permissions as well. And finally, Keeper Secrets Manager will also help them rotate passwords, SSH keys, and service account credentials that the application would need in order to run. So your applications, they only access their part of the vault, and the passwords, the keys that they retrieve could be different every time. Keeper Secrets Manager leverage the advanced encryption model of the Keeper platform, and that's the whole point of using Keeper Secrets. Everything will be in a unified solution in the same vault, basically, that is already using advanced encryption to protect your data. So everything about encryption is described in our documentation portal. You will find a section specifically for that. Here we'll talk about our zero knowledge and zero trust approach to the vault. Basically, zero knowledge means that everything is always decrypted on your side, with Keeper never being able to access your decryption keys. No one at Keeper Security can basically decrypt your vault. We only host ciphertext for you. So in order to access the vault itself as an end user, you either use a master passwords or SSO, and in that case, you don't have a master password at all. If you have a master password, then locally on your device, we will derive it with 1 million iteration of PBKDF2 that will generate the master password key. And this key will be able to unwrap the data key of your vault, which is a first AES 256-bit key. Then the data key does not decrypt your data directly. It will decrypt the other keys. If you have 10,000 records in your vault, we will decrypt 10,000 AES 256-bit keys at that point. We call them the record keys. Then individual record keys are used to decrypt the entire records. That could be certificates as a file attached. It could be a password. It could be a private key. It could be really anything here. If you are using SSO as an end user, then we leverage elliptic curve cryptography. Each of your device will have its own elliptic curve key pair, a private key that never leaves the device, and a public key that has been used to encrypt the data key of your vault. So using the private key, your device can decrypt the data key and then use the data key to decrypt the rest. So this is this advanced encryption model that Keeper Secrets Manager leverages. You will find specificities, how Keeper Secrets Manager leverage that in our documentation portal. So of course, we will use the records level encryption model. Each secret is basically a record that is encrypted with its own key. Each of those record keys are then encrypted with the folder key, the shared folder key, and your application key that is client-side generated will be able to decrypt the shared folder key. Your application could be running on as many instances as you want, as many clients of the same application, basically. Each client will also have its own AES 256-bit transmission key that is in addition to TLS. And we use that to protect you against man-in-the-middle attacks. So everything that is transferred on this pipe is leveraging the at-rest encryption model I mentioned, but then in transit, we also use a really advanced encryption model. So that was for the boring part, all of the technology parts. But what we do as Keeper is basically make complex tools easy to use for the end users. We want Keeper to be easily adopted by anybody in the company, and that also includes your DevOps department, your developers, your IT departments. Here, I will open the vault of a user that has a role that gives them access to Secrets Manager. As this user will have access to all of the features that all of my colleagues in the same organization would have access to. So basically my vote here, where I have access to different folders, share folders to collaborate with my colleagues, with my departments, my team, my projects, etc. I will also use my browser extension to navigate through the web every day and have everything auto-filled, password rotated on those websites as well. But what is in interest of us today would be this new tab here, Secrets Manager. This is where this user will be able to create the identity of each of its application. So here you see a list of applications that this user created already. He will be able to create new application at any point of time just by giving it, and then provide access to that application to a first folder. Once you save this application, it will be in the lists, like that one, for example, demo app. Demo app could be really anything. Here you see demo app has access to one shared folder in here, My Secrets. It has edit permission, and demo app has been deployed 220 times already. I will get the list of all of those devices, instances of my application, basically, in here. And at any point of time, I could just block the access to one of those instances. I just need to select them, delete them. Those servers cannot talk to Keeper anymore. So here we'll just jump into the Keeper Secrets Manager documentation. Because Keeper Secrets Manager is leveraging a zero-knowledge encryption model where everything needs to be decrypted on the application side, basically, that means inside your application, you will need to import to use the Keeper tool. So we have different ways for you to use Keeper Secrets Manager really easily, either using an integration. So we will provide you with an integration with most of the tools that your DevOps team are currently using every day. You will find tools like Ansible, Terraform, CI/CD platform like GitHub, GitLab, Jenkins, containerization technology, Kubernetes, Docker. You will also find other secrets manager Vault in here. The goal is that if you are already using something like Azure Key Vault or HashiCorp Vault, for example, and you want to unify everything using the Keeper Vault, we will not ask you to rewrite all of your codes. Keeper will also be able to synchronize and control those other vaults automatically for you. So yeah, there are other ways to integrate as well. But then if you're a developer and you build your own application, we will provide you with Keeper SDKs. Python, Java, JavaScript, .NET, Golang. We also have a PowerShell module as well. That would be useful to directly from your source code to integrate to the Keeper Vault. I will show you an example here with Python here, just to show you how simple it will be for your developers. At the beginning of the code, you will need to import the Keeper tool. So in that case, that would be an SDK. That would be just a simple import here to import the Keeper Secrets Manager SDK. Then your application, they do not authenticate as you. They don't know your email address. They don't know your master password, maybe to access the vault. You will deploy them using either a one-time use token or a config file. If you go into your vault here, let's say I want to deploy demo app in a new client, a new device that is using the Keeper Python SDK, let's say. I will do edit here, edit the demo app application, add a new device, and call that one my demo instance, for example. Here, Keeper would ask me, do you want to use a one-time access token or a config file? If I generate a token, for example, my Vault will give that token to me straight away. It's not saved anywhere. It's up to you to download it or copy that value and paste it into your source code. This token is a one-time use, so you can leave it behind you. As soon as your application has run one time, that token cannot be reused anymore. I will show you an example here with a running example of a Python code where I will do a simple use case. So here you see in the documentation, this SDK has a lot of different features. You could download a file that is attached to Keeper, create a new secret, update secrets. But a simple use case would be how to retrieve something from the vault from your application. So here, this is the initialization code that I mentioned before. And here, getting a secret is basically one function is the SDK, get secrets. And here you see I have been using a keeper record unique ID, which is a pointer to the right entry in your vote. So that's where you could basically query exactly the data that you want from the vote. I have a running example here where I have a Python application that is basically a nice UI here. It's just a simple pop-up where I've added this button, query votes. If you look at the source code in the left-hand side, I have basically consumed this token already, but I can still leave it in the source code. I can share this source code. No one else would be able to reuse that token anyway. But here in the code, so I have initiated Keeper Secrets Manager, and then my code is just generating a new window. And from that window, I will have the button to query the vote. So my button here is simply calling this function, query vote. And this button is basically querying a specific unique ID of record in my vote. I will just copy this value just to show you the keeper record inside the keeper vote. And when the application runs, it will specifically query a custom field from my keeper record, and the name of this custom field is value from the vote, and then it will simply display that value. It's just a simple sample code here, just to show you how easy it is to query something from the vote and do whatever you want with it. It could be the password of the database, so that way your application does not have in the source code the database password, but when it runs, it will retrieve from the vote the actual password. So here, if I go into my vote and search for the keeper unique ID here, I will find this keeper here, this keeper record, sorry, here. And you see this entry only has one custom field. I will edit the record just to show you. Only one custom field here, named value from the vote. And this is the value that is actually stored. So you see it ends with 1, 2, 3, 4, 5, 6. I will cancel this, just display the value here. If I go back to my application and click on query vote, that's the value that would be retrieved straight away. If I change this value here, just come here and just do, this is a new value, and I will add that to the end of the string. As soon as my keeper vote is up to date, I can just run my application again, and you will see the current value return to your application as it runs. So this is a great use case where you can see that if your password had changed in the meantime, your application will be able to retrieve that new password again from your vote fairly easily. Your logic in your source code could easily query the application password as soon as it needs it. So that was just one example using a Python SDK, but of course we will, with the integrations, for example, it automates the CI/CD, your pipelines there when you deploy your applications. Here, this is another example where I'm using Keeper Secrets Manager CLI. If I go back to my documentation, you will see this is the third type of Keeper client you will find. This time it's already ready to use. So it will run on Windows, Mac, and Linux. It's basically an executable that you can just call from your external application. And this is exactly what GitLab will use during the build there, during the job, to retrieve something from my vote. So here the script that GitLab is running is fairly simple. It's basically retrieving a password, something stored in a custom field. It could be an API key, for example, and also download a file attached into Keeper. So here you see I'm using Keeper notation here. I'm running KSM, so the CLI tool, then the secret function notation, and then a link, a URI that points to the right value inside my vote. Once again, it's using a unique ID here. But then with the Keeper notation, you can just specify if it is a field, a custom field that you want to query, or a file that is attached as well. And then here, the value at the end is the title of that field. So I just copied the unique ID of this record, and same thing here. I will just search for this unique ID in my vote. So let me just grab this value here. Let's do copy, go back to my vote. Here, this is the record that GitLab will query. You see it has three informations. So the password here, there is a file attached that could be a certificate, for example, and there is also a custom field that could be an API key, for example. So then in my script, I would just echo those values and use more to display the content of the attached file. If I just go to GitLab and just run that job again, you will basically see all of the steps from my script getting executed, accessing the vote, accessing those secrets, those sensitive values, basically without having any of those in the source code that I was showing you before. It's only as it runs that it will be to authenticate and access the right data. So when you authenticate, it will basically generate logs over there that you will be able to retrace exactly which instance of the application was able to access that vote. Just wait a second for the task to run. And yeah, you see here the export function, and then this is, yeah, echo. You will see the password here displayed in clear text, my API key that will be displayed as well, and the contents of the text file as well. So as an administrator, you will be able to retrace exactly who did what, but also as an end user, you will have access to the logs of your application from your vote directly. Here from my vote, I have access to my GitLab logs from there. Earlier, I was showing you maybe the replit tests. Same thing here. I will see when the replit platform, the Python application, was able to access that specific folder. So I mentioned that because the application does not know those infrastructure passwords, those API keys, SSH keys, maybe certificates, when you have to rotate them, it will be a lot easier because as soon as Keeper is up to date, then your applications are up to date as well. From the vote itself, the Keeper vote will be able to automate the password rotation. So here I will show you an example, for example, with a Windows service account that is in AD. Inside my Keeper vote, I will provide the admin account that my Keeper component will use inside my network to perform the rotation. And this is the Keeper records where that user account is defined. So here the rotation in Keeper is using specific templates that Keeper provide you with. We call them rotation records, and you will find those in here. Out of the box, we can do the rotation in database directory, so OpenLDAP, AD, a standalone machine as well, so Windows, Mac, and Linux. And then you will find the PAM user record type, which is basically a user for any of those three platforms. So here you see above is a PAM user record type. If I edit these records, you will find my password rotations straight away inside the vote. This is where I specify my admin credentials in here, and also if my rotation is on demand or based on schedule as well, the new password. And here, this is my Keeper gateway. My Keeper gateway is a component that is inside my network that is able to contact the different appliances, devices where I need to do a password rotation. So here, I will just save this record just to show you that this is the current password for the service account. If I ask Keeper to do a rotation now, my gateway already got the request from the Keeper Cloud to push a new password on the remote system. The remote system accepted it, so it pushed it back into the Keeper vote. Here, inside Keeper, I will also be able to attach post-rotation scripts that will allow me to automate specific things that you need to do after a password rotation. Here, I will select PowerShell scripts that we provide you in our documentation. That's a good example. That use case is with Windows services. Windows services, they do not use Keeper Secrets Manager out of the box. They would locally on the device store in the service configuration the service account password. So I will be able to attach the script here. And what I'll do is I will display in the right-hand side a Windows box that is actually running this service. I will be accessing my network using Keeper Connection Manager, which is a secure way to access my remote devices. I will connect to this Windows box in here. And here, this is the service I was mentioning. If you click on log on, you see it's running as Bob, this service account. And here you see the service is running. If I ask Keeper to do a new rotation on this service account, you see a new password has been pushed in AD. It's up to date in Keeper. My applications that are querying it will get that new password. But now if you look at the status of that service, it's getting stopped automatically by my Keeper gateway, reconfigured with the new passwords, and it will start again. So this Keeper gateway is fairly easy to deploy. It's only generating outbound traffic. So you install it on Windows, Mac, or Linux in a few minutes. That service starts, goes out to the web to keepersecurity.eu or .com or to the region that you are hosting on. And then it will wait for the cloud platform to request something. Everything will be documented in here. In the Secrets Manager documentation, you will find a nice section for password rotation and consequent section for post-rotation scripts where we give you examples. The one I was showing you was about rotating the credentials of a Windows service, but here you have full control on your post-rotation script. You could basically design whatever you guys want to do.
Okay. Yeah, thank you, Sylvain. I think we're going to run out of time to answer questions. I am trying to answer questions as they come in live. But if anyone would be interested in learning more, feel free to go to keeper.io/free, book a demo there, and we can get you set up with a free 3-year plan for our personal password manager subscription. Yeah, no, this was great. Thank you, Sylvain. I think one thing we can add about Keeper Secrets Manager is that we really integrate with all domain providers, the identity of providers and everything. So super easy to set up, super easy to use. Yeah, thank you so much for your time. And yeah, feel free to reach out to us if you'd like to learn more. If you have any specific questions, any technical questions, we'll be happy to answer them all. Thank you, everyone.
Thank you, everyone.